Section 8.4, the equations of sinusoidal functions. We're going to be using Desmos for this activity, and here I've set up Desmos, and I've written y equals a sine x. And you can do something where you can actually put a slider in. So right now a is equal to 1. And what I want to see is if I increase the value of a, so if I go up to 2 or 3, what in the graph changes? Okay, and then if I go negative, what changes? So it looks like my x-intercept stays the same. My period, how long it takes until it repeats itself, stays the same. But it looks like a affects my amplitude. Okay, so a affects amplitude. Now if I were to turn that graph off, now this graph I'm going to look at the value of b. Look at what x is multiplied by. And so here I have just a normal sine graph with b equals 1. This is a regular sine graph, an amplitude of 1. And now if I change the value of b, it looks like I'm changing the period length. If I get a bigger value, I get a shorter period length. So here I have 4. It repeats every pi over 2, or as opposed to when I had it just normal, it repeats, I can't find the number 1, there we go, it repeats every pi. So it looks, or sorry, it repeats every 2 pi. So let's go from 1 to 2. I think I can even just enter it in. At 2, it repeats every pi. At 4, it repeats every pi over 2. So there's some relationship between b and the period length. And again, if I make the b value negative, it looks like it does something similar. So let's look what happens when I go negative. Oh, interesting. It inverts it. Okay. So a was amplitude, b affects period. Here I have c. And I should start with, there we go. So we have to start with c equals 0. That's the regular graph. A regular sine graph. If I increase the value of c, it looks like I'm just shifting the graph. If it gets bigger, I shift to the right. If c gets smaller, I shift to the left. So c seems to help me shift. D value, so if I go x minus something in brackets, it's the sign of everything in the brackets. If I have y equals sine x and I subtract a number, so originally we'd always have 0. So there's my original graph. If I subtract positively, I move down. If I subtract negatively, I move up. So it seems like I shift. So let's look at the summary of all this information. Any sine function can be expressed as either a cosine or a sine. So this is our general form. Y equals a sine b, x minus c plus d, or we can also express it as cos. With the following characteristics. A is the amplitude. If we wanted to find the amplitude, we go max minus min divided by 2. So A determines amplitude. B is the number of cycles in 360 or 2 pi. The period is 360 divided by b, or 2 pi divided by b. That gives us our period. Because a regular graph has a period of 2 pi or 360. Every 360 degrees around the circle, we start repeating. Every 360 degrees on the graph, we start repeating values. The value of c indicates the horizontal translation that has been applied. So c tells me if I'm moving left or right. D gives me the equation of the midline. Y equals d, and to find the midline, we would just go max and min divided by 2. So the maximum value is going to be d plus a, the minimum value is d minus a. In a graph of a sine function, c is the distance from the vertical axis to the first midline point. That's the value of c. In the graph of the cosine function, c is the distance from the vertical axis to the first maximum point. So some other ways to find c. Okay, let's try us a question here. Consider this function. Describe the graph of the function by stating its amplitude, its equation of the midline, its range, period, as well as relevant horizontal translation. Verify your description by drawing the graph of this function using graph technology. Okay, so let's first of all label this as A, because our general form is y equals A cos bx minus c plus d. So my A value is 2. My B value, so what's multiplied to B, is 4. There is no C value here. It's not 4x minus 1. It's 4 to x and then minus 1. So a little bit different there. So my C value is 0. There is no value subtracted. And my D value is 1. Okay? So A tells me my amplitude. My amplitude is equal to 2. My equation of the midline, to find the equation of the midline, I go y equals d. So in this case, y equals 1. My range, so that is my y values. Where does it go from max and a min? Well, my max is going to be 3, and my min is going to be, since my midline's at 1, I go 2 down as negative 1. So my y is always going to be greater than or equal to negative 1, but less than or equal to 3. I go between 3 and 1 is my range. Okay, to find period. Period is 2 pi over b, or 360 over b. Okay, so 360 over b, my b value was 4. 360 divided by 4 is 90. Or I could have said 2 pi over 4, which is pi over 2, which is 90. As well as the relevant horizontal translation. So remember our horizontal translation, how much it's horizontal is given by the value of c. Since c is 0, there is no horizontal translation. So now to check our work, we're going to actually graph this. We're going to do just the graph of cos. And I'm going to hide all these and I'll just start a new one. So y equals cos x, and our new equation was y equals, what was it? 2 cos 4x minus plus 1. Okay, I'm showing a little bit too much stuff. I don't want this graph on there. Okay. So I said, let's look back to what I said here. I said the amplitude was 2. The midline was y equals 1. The amplitude is 2. That makes sense here. So here, my midline was there. My amplitude is 2 down or 2 up. I said that the period was every 90 degrees or every pi over 2. So what I'm saying is I'm going to start repeating again at pi over 2. Very good. I said there was no translation. Look, we start with a maximum, start with a maximum. Same idea. Okay, so those values of A, B, and C are going to tell us about what the graph looks like, and then we can always check by graphing. You're going to come across questions like this. Match each graph with the corresponding equation below. So what we're really looking for is amplitudes and other qualities. So let's look at this first one, what its amplitude is. So it looks like I'm 3 units below and 1, 2, 3, 4, 5 units above. So it looks like my midline would be somewhere here, and my amplitude is going to be 4. So because my amplitude is 4, I know it's going to be one of these ones. A couple other things I could tell, I could look at the period. So it looks like it starts here, and then it begins repeating again right there. So it looks like its period length is going to be that long, and then it starts repeating again. It looks like its period is every 120. Each of these squares is 30. So 360 divided by b equals 120. Doing some algebra, we would see times both sides by b, then divide by 120. b equals 360 over 120. 360 divided by 120 is equal to 3. So I've already said it has to be one of these guys, but then it also has to have a 3 in front. So I've taken out that one. So 4 sine 3x minus 60 plus 1 and 4 cos 3x minus 60 plus 1. So which one of these are we talking about? So a sine graph, we know starts with a amplitude. So sine, starts at 0. It looks like that. But here we have a shift. We said we've shifted it over 60. So in order for it to be a sine graph, it had to have been translated 60 over, 30, 60 right there. So that makes sense there. The 1 means we've had a vertical shift. We saw that with our midline. So it's definitely going to be this one. But what about this cosine graph? Remember, cosine graph generally looks like this. So in order for it to have been a cosine graph, in order for its maximum is normally at 0, it had to have been shifted 90. Okay? So it looks like this one has been shifted 90. So this is definitely a possibility. Let's see, does it have an amplitude of 4? Yes. But what about its period? We got to look at its period here. And that period just doesn't work out because this is saying its period, it has to be 2 pi, and that definitely does not have a period of 2 pi. So I think graph A must be that one there. We follow the same steps here to try and figure out what graph this is. It looks like a sine graph, I'm going to guess, and then we just have to look at amplitude and a couple of other. But this video is getting a little long, so I'm going to stop it there. But that's the process you go to. Always remember that you can check things on your graphing calculator. Make sure you've watched that video that Adam made about how to use Desmos. That will be helpful as well.